In this latest edition of Baya Systems' Tech Threads podcast, we welcome Fabrizio Del Maffeo, founder and CEO of Axelera AI, which is rated one of the top 10 hottest semiconductor startups in the field of artificial intelligence. Fabrizio, apart from being a great technologist and leader, is an excellent visionary and communicator. So join us for this insightful discussion.
Welcome to Tech Threads, Weaving the Intelligent Future, the podcast exploring the fast-paced world of technology. In each episode, we dive into the latest innovations in data movement, AI acceleration, and the transformative potential of chiplet technology. Join us as we explore the breakthroughs that shape the future of computing and hear from industry experts on what's coming next in the tech landscape.
Hello, and welcome to the fifth edition of Baya Systems' Tech Threads podcast. I'm Nandan Nayampally, Chief Commercial Officer of Baya Systems. And today we're excited to welcome Fabrizio Del Maffeo, a very dynamic leader who's also the CEO and co-founder of Axelera AI, a Netherlands-based startup that was recently rated by CRN Channel to be the second in the list of hottest AI startups, especially semiconductor startups, to look out for. Welcome, Fabrizio.
Thank you for having me here today.
Well, we're excited to have you here, and I know you've been jet-setting around, so instead of me telling people about you and Axelera, why don't you do that? Give us a little bit about yourself, your journey, what brought you to Axelera and what Axelera is trying to do.
Well, I'm an engineer, trained as an engineer. I have worked for 20 years in computing in companies such as Advantech, ASUS. In 2015, I launched a product line in a Kickstarter, which eventually became a division of ASUS. In 2018, together with Intel, we launched the first AI accelerator for edge devices, powered by Movidius technology. And in that moment, I saw very strong tractions. A lot of customers wanted to get the hardware. But the solution was not performing as expected. Therefore, I saw an opportunity, a market opportunity. I saw the needs of something different, and I decided to quit. I took a couple of years to put together a team, finding right people, finding the money. And eventually, the 9th of July of 2021, we started Axelera AI.
Cool. So Axelera is clearly focusing on edge AI at the moment. At least that's the starting point. What makes edge AI so fundamentally different from traditional cloud-based AI?
Well, the requirements and the constraints are different at the edge. If you think about edge, means devices in the physical world. It means that you have constraints of power consumption. You should be lower. You have to control it. And a lot of devices are battery powered. Other devices, they are failless. Then they cannot have big fan, and therefore computing power should be lower than the cloud. There are constraints of cost of the device, because you are transferring the cost to the user. You're not anymore getting a service, but there is a person, a company who's buying it. And on top of this, there are also constraints that maybe there is no bandwidth to transfer data. You have constraints of security, needs of security, needs of safety. And therefore, all of this together means that it's necessary to have a completely different technology. You have to reinvent the technology if you want to run AI algorithms, neural network applications inside edge devices. And this is why we exist. We cracked it.
So I actually am excited about it because, as you know from my past life, I was at the neuromorphic AI company called BrainChip, which is also focused on edge AI. And in a lot of ways, when I was at ARM, we were looking at how does compute go towards the edge. We know it's going to move towards the edge as opposed to always being in the cloud. That's the only way it's sustainable. And I think you're probably going to work on the word sustainable as one of the fundamental aspects of why edge AI exists, right? Now, I want to also help the audience kind of differentiate between what's kind of sensor edge, which is where you're pretty much wearing the device at a very and much lower power budgets, form factors, etc., versus the network edge, and also understand where Axelera fits into this space.
It's a good point, Nandan. As you correctly said, we call it far edge, the end device, which can be a phone or can be a camera. Axelera is playing in the network edge, inside what is called the gateway, right? This computer that is collecting data from multiple sensors, can be multiple cameras. And because we believe that the biggest opportunities lays there, in the sense that if you think about in the world, there are 1 billion cameras, more or less. Replacing all this camera takes gear, effort, and a lot of money. Then if you want to enable in a market like surveillance, artificial intelligence, the easiest way is to place a computer, an intelligent computer, an intelligence device close by to the camera. And is there where essentially our technology makes the difference.
Indeed. And in fact, we look at edge being camera for most part, maybe voice, but you're also getting health and sensor data. Now, obviously, there is intelligence at the edge that captures the right data as opposed to everything else. And then, of course, you can't do that level of compute on something as small as kind of a body-worn device often, right? And so that's, I think, where you're saying you'll see more aggregation of compute at the network edge or the far edge, near edge, as opposed to at the sensors, which are sources, but rather than truly intelligent. Is that fair?
Absolutely. And also the problem is that if you look back only 3 years ago, LLMs, large language models, were not around, right? This shows that it's unpredictable, the future. You don't know what is going to happen. And then you have to be flexible. You have to have an architecture which can easily evolve and a solution which can cope with the pace, with the fast speed of the technology. And if you want then to do so, the best way is to focus on that edge, on the network edge. Today we started as Axelera, for example, in computer vision with simple convolutional neural network, but today we support VLMs, small language models, because the market is evolving at speed of light. And the requirements are very different, are constantly changing, and we have to adapt. Company has to adapt fast, and then you need to have a flexible technology, scalable technology, but also think where you want to play inside the big field of AI.
I think that's well put, right? So the only thing that's constant is that it's going to change. And in fact, what you see with structured state space models or DeepSeek are software innovations, model innovations that bring more efficiency to the compute or increased accuracy to smaller compute, which plays well to the edge, especially inference at the edge. So on that front, right, you guys are focused clearly. If it's very model specific, then the hardware becomes redundant very quickly. So what are you doing to make sure that you are able to adapt to the newer models?
Yes. The good news is that if you look inside any model, 70 to 90% of the operations are simple vector matrix multiplications. Then 70 to 90% of what your machine is doing are just multiplications between numbers. And therefore, what we did is developing a specific technology called digital in-memory computing, which is extremely good in performing these operations at very high speed with very high throughput, moving a little the data, which means low power consumption, and also merging the memory and the computing in the same area, reducing the cost. And this allows us to accelerate all of this. On top of it, we had to add a RISC-V technology, and including vector instruction sets extension, to allow us to be programmable. Because as you correctly said, we don't know what we don't know. Right? We don't know what we have to support in future. For sure, there will always be this vector matrix multiplication, or at least in coming 5 to 10 years. There is no reason to shift from out from this. But it's really important to be programmable, and our technology is programmable.
Yeah, it makes sense. I think there is a fine line between what is hard-coded and what is programmable. And you, in this era of change, you can't be too vectored to the vector, let's say. Sorry for the bad puns there. But actually, this leads me to the real question, right? So AI is computation, sure, but it's finally about data, right? In distilling intelligence, distilling information, distilling and using that forward. So having come from compute myself, the world seems to focus on the computational widgets more so than the fact that you have to move data efficiently. In fact, how you efficiently do data movement in AI is probably a critical piece of what makes you sustainable or not, whether it is, as you say, in memory computing, but also how do you scale all these growing nodes? How do you actually position it in the data center? So can you speak a little bit about the role of data movement and data efficiency in this space?
Yeah, so the data movement is the key. And if you think about the big difference between networks, which we used to run 3-4 years ago, into the networks, is the size of the network, which exploded, which means more data transfer, which means needs of more bandwidth, which means more memory, and eventually connecting more compute, right? Then it's the problem of scaling up has been solved, but the problem of scaling out is a different story. Then it's easy from just to try to explain it to design a chip with 1 core, 4 core, 16 core. Has some complexity, but it's solvable. But when you start to connect multiple chips in maybe not even in the same rack PC, then it's a problem of data movement and orchestration, which requires different interconnect, which requires many other things. Our technology solves the problem within the chip. What we do extremely well is the computational part and the internal data movement. We minimize that. But clearly, when you scale, you have to solve also more complex problem, which we are working on today already, because we are scaling further our technology. But it's a good point, right? It's necessary to consider the big picture that includes also the interconnect between chips and the bandwidth to the memory, which represent a bottleneck in many applications, or at least in all the large language models. While maybe if you go to models like diffusion networks, that one, they are more compute bounded than memory bounded.
That's true. And in fact, I think there's one nomenclature that we think is slightly different between you and us at the moment, right? So what you're talking about increasing the compute and the efficiency on die, right? We're calling it scale within. And in fact, that's actually one of our raison d'etre about being here, is how do you make these things more efficient? How do you make them more flexible? How do you improve topologies within the die? But also, as you say, scaling up now involves multiple things. Can I put down 6 chiplets in the same package to do that? Now, how do you actually create the network that goes across? How do you make sure it's efficient? How do you understand it's going to do what's needed thereafter? And then what NVIDIA calls scale up is then actually using something like an NB switch to add more kind of compute elements in there, right? And I do think that this is an interesting area where there's a lot of innovation. I would actually argue that scale up's not solved yet. Scale within is what we're looking at. Scale within package is what we're kind of looking at next. And then scale up with NVLink, UA-Link, all worried about how do you scale up beyond 72 nodes in the rack. It's a non-trivial problem. And I think both of us have a very good approach that may help at least address or at least accelerate some of that scaling.
Absolutely, and clearly that is a unsolved problem, as you said. What we call it scale it out, because you get outside the chip, right, or outside the system, right. But it's a problem to be solved because NVIDIA is a provider, but in general, it's a big problem for the market. And today, as Axelera, we are still in the edge space where there is no needs. Also in the entry-level server space, which is another market that we are targeting, we don't have this need. But clearly in the future, I think all this deep tech sector has to solve and democratize this, and I like democratize because we should have multiple providers and it should be a trivial solution, become trivial in coming 5 to 10 years. Today, it is not. On the other hand, we don't know what we don't know. We don't know how large the network will become. Are we going to scale further? Because if you look at the results of the latest model, this incremental increase of parameters does not reflect in a large improvement of performance. Actually, there are also companies which believe that in the future you will have hundreds of specialized reasoning agents running independently in different systems and then talking to each other and orchestrating between each other the tasks to be solved, and which means less data transferred outside system. Unfortunately, I don't have a crystal ball, then I don't know how the future will look like, but I'm very curious and interested to see and excited to have the chance to live in this future and probably and trying to help building it.
Indeed, I think that's what drives us as startups in particular and technologists in general, right? I do think we are equally excited by what we see. In fact, most of our work is in what I call scale within, what you call scale up within your systems. And there is so much more you can do with topologies, with clustering, with understanding how to optimally partition within a chip. And then also with the new emerging technologies with like chiplets, right? You can actually scale more rather than having to go off chip, off board to the rack, right? So I do think that we're going to be seeing a lot of each other in these marketplaces where there's going to be synergy, engagement with as partners try to change the cultural mindset of how all of this is done.
Yeah, but I think that the problem, if we can call it problem, is that everything today is done essentially developed on one architecture. Mm-hmm. And as a consequence of it, all the rest of the world has to adapt. Right?
Yes.
To that architecture, which is used to train the network. I think that in coming 5 to 10 years, things will change. There will be multiple solutions available also to create models, to design models. And what is called hardware-aware training will become more and more popular. Therefore, you will see more and more models, custom models, used by companies and optimized on specific hardware solutions. And this can change completely the dynamics in the market. We see already today ourselves, because we recently developed internally a couple of networks optimized on our architectures, and we see the difference in throughput, efficiency, and so on, because we are targeting our architecture in the moment we design the network. And these are just proof of concept, but this is another dimension to solve the problem without adapting to the others, right?
Yeah, and I think speaking of cultural mindsets and leading to things like what you see with democratization of processor hardware as well. So RISC-V is an open source architecture that seems to be going across. A lot of different sovereign nations are looking at, I want not to be beholden to one particular architecture that may be outside my control. I want to build a platform that is scalable and somewhat protected from, let's say, economic warfare. So you've been doing quite a bit of work on that front. I'd love to understand how that's going, and if you can explain to our audience what that is.
Yes. Essentially, Axelera today is the largest AI semiconductor company in Europe, although we are young. Clearly, Europe is lagging behind in deep tech compared to the United States or China. But our positioning is helping us a lot to grow the company also within Europe. Europe has recently, over the last years, faced multiple challenges, starting from a war, which is close by and is still going on, but also political shift, right? Global strong changes in the political scene, right? And this concept of sovereignty is becoming extremely important. Europe realized that there are no companies able to design high-performance computers. There are no companies able to design AI computers. There are no companies providing fab, or there are no fab in Europe. And therefore, I think that the global political situation helped Europe to wake up and to realize this. Axelera, being the first company in terms of size, but also the only company having a chip on the market today. You are a European company with a chip with technology which is proven and used by more than 200 customers, has been selected to design a specific AI accelerator, which will be deployed as a sovereign solution inside AI high-performance computing center of Europe, and in future to power the AI factories and gigafactories. What are these AI factories and gigafactories? Are large projects partially sponsored by Europe, where Europe intends to have these huge AI factories with at least each factory should have at least 100,000 GPUs equivalent hardware to be a little bit more independent. Last Monday, there was the announcement that 76 consortia applied to the call, proposing more than 3 million equivalent GPUs to be deployed in coming 3 to 5 years to Europe. We are very excited that Axelera can be part of it, but thanks to the fact that we are designing an accelerator, and this accelerator can be also deployed in volume. But clearly, we are a global company, and it's great to supply to Europe our hardware, but we are playing a global role. For us, United States is extremely important as a market, and we want to play a big role there.
So let me ask you this, right? So clearly, there is an interesting change in how you approach AI and Edge AI in particular. One of the things that is driving NVIDIA's success is the software platform and stack that they have. How does the new movement, shall we say, enable both innovation in this software, where the software stack, the libraries, the ecosystem is critical, while keeping it flourishing as people innovate with it?
Yeah, it's I think the software is the key, right? It's really the key in AI. People think that, non-expert think, okay, we just need a chip. No, the chip is a piece of metal. It's like the engine of the car. You need a complete car, right? And you need the driver, which is the software, essentially, and you need the data, which is the gas for the car, right? Then I think that's or nowadays is clear, right? Because if you see NVIDIA and you see AMD, you see the gap between these two companies. If you look at the hardware, well, there is no real gap. AMD is doing great. But if you look at the software stack and the deployment, the gap is huge. Luckily, we all woke up, and I think more and more companies, including ourselves, are trying to contribute to the software stack, publishing on GitHub the software, having most of it open source. Tenstor and Scrive is doing the same. Other companies are doing the same. I think there is a strong need to democratize the software and all together to try to unify it and to have a platform which are interconnected, because this will help the market to evolve and to accelerate. If you want a real democratization, you need also this part which is not yet there, and it's painful because we as a company we went through it, in the sense that we had the first chip 2 years ago, but it took time to fine-tune the software, and I'm extremely excited when I see the latest release of software which we published last week, and you see how flexible it is, what we can support, the fact that we introduced a large language model, the fact that by the end of this year we're going to have an integration with Hugging Face libraries, then all things that require time, effort, but that can happen only with open source ecosystem. And it's extremely important that many companies will follow this approach.
I think that's kind of well put, right? So me coming from a hardware background, kind of a processor head of sorts, I realized two things. One, it's not just about processing or about data movement, but well above that is still silicon speak, right? It's finally about software. What it runs on is hardware, but what you need to do is to make sure software runs. And so the fact that the rest of the industry is now pooling resources to catch up to the giant, so to speak, is necessary. And that kind of leads me to, the point about how do you actually reduce the barrier of entry to edge AI, right? So you've talked about the software stack being there, a plethora of silicon being there, but I'm going to pull you to a topic that's close to my heart, which may or may not have expected. You can deliver open source software, it's going well, but in terms of scaling innovation or scaling best in class, chiplets are emerging as potential pieces where you could be not selling your chip as much as enabling other designs with chiplets, right? So where do you see that going, and what are the challenges? Because that's clearly where we're focused on helping the broader customers.
Well, we believe in chiplets. The platform which we announced called Titania, which we are designing for this large European consortium, and which will power in future the high performance computing center, gigafactories and factories, is a chiplet-based platform. We strongly believe that is the way to go to scale. I mean, the monolithic approach has a lot of limitation. It's great when you are at the edge, because you want to optimize everything. When you want to scale, chiplets represent the future. We believe it. I think we are still 5+ years far from combining multiple chiplets. Because while the company like us, semiconductor companies like us, fabless company want this, actually, provider of silicon, they don't like it at all, right? The fab, they don't like this. The IP providers, they don't like this, because it's a threat for them, right? You can start to play around. Large corporations, they don't like it. And if you look, what is the impact of this is that while, for example, AMD believed in this many years ago, were the first company to really do so, right? But what happened is just that you cannot see today any heterogeneous die out there. It's still, we are not still there, and I hope it will happen. Because if you want to democratize, as you correctly said, also the hardware, you have to. And we love this idea, even because we as Axelera, we always said we are ultra focused, laser focused on inference, AI inference. We don't do anything else than this. But we also know that as a consequence of it, we still need an host CPU. We still need a complementary product, right? And we are completely fine, and we love the idea to partner with other semiconductor companies to enable the complete solution which is very different if we are talking about automotive versus retail versus security, at least the final solution. But the core, the component at the core can be the same if it's only high inference, or for example.
I think you hit the nail on the head, right? So we actually being now focused on that market, we see, and from my past life, I gave this example that 2008, when I was at ARM, we were building a hard macro of CPU cores, and my colleague said we should think about chiplets. My view then was, okay, it's about 10 years away. We should think about it, but it's 10 years away. And we're now, 17 years from then? But really what I think is, like AMD showed the way that this is really a way for you to scale and both get the benefits of yield, the benefits of cost control, reducing risk overall. But it's in a more walled garden approach where they control the entire stack. Intel's done it as well. NVIDIA's doing it. The idea of trying to mix and match different vendors, I think, comes with multiple challenges. Interoperability is one. But I do think that the economics of that are getting to the right point. But however, the risk hasn't been solved. Who takes responsibility if something goes wrong? Right? And I think that part is probably the bigger problem than just having availability of chiplets thereafter. But, and this is where I think my question is going to you before, smaller companies can actually use that efficiently to have multiple SKUs, rather than take on the risk of multiple tapeouts, right? And as that ecosystem for individual companies improves, I think the rest will follow. So it may be 5-7 years of where pure marketplace of plug and play, but I think there's going to be steps in between that help us go towards it. Would you agree?
Absolutely, I fully agree. And this is also our approach. It's the way to reduce development cost, but at the same time, it's also having offer multiple SKUs essentially, because you can package different chiplets in a different way, or scale the number of chiplets between the same package, and it's the way that we want to go in the future. It is absolutely the way. I just, I'm as a founder, I'm also a little bit a dreamer, and I would love to see sooner than later a world where I can, I don't know, take a Tenstorrents chiplet, an Axelera chiplet, an Intel chiplet, and each of them bring something different, and we can create a product. Maybe each of us can do it, right? Like today, I'm buying IP, right? Me as Axelera, I'm buying IP for PCI Express, right? So I don't design a PCI Express IP. I don't design, and I just buy them, and I take the ownership of transform that IP in a chip. In the future, why not? Why not do the same, but just taking the chiplet instead of the IP? Well, it's not so big difference. It's just that it's not easy to be done, and it will require a few years probably.
No, indeed. And I think you've hit another of my statement points, which is a chiplet is like a hard macro, except it's fully delivered as opposed to just the mask set, right? And in fact, takes away some of the integration challenges. Yes, it adds to the packaging challenges, but packaging challenges are well understood by one group as opposed to another. So I think what you said is very valid, right? Once the granule of efficiency specialization becomes such that the cost factors lean towards chiplet rather than IP and building, it will happen once you've solved the risk problem.
I think that there are, if we want to make it happen, like everything, right? You need to have a reason, and typically the reason should be a customer or an industry which requires something like this. And at least in Europe, we see that, but not only in Europe, I would say it's becoming global. That automotive industry can be the industry where it makes a lot of sense, the chiplet, because you have volume. For each single car, there is a volume of production which is significant, which is an incentive for everybody to sell, to design a chip for automotive. And on the other hand, you have a lot of fragmentation, because there are plenty of models out there which have different requirements in terms of AI, safety, and so on. Therefore, hopefully, we will see this happening, probably starting from this kind of markets. And here in Europe, there is a consortium that is doing this. We are part of it, with not the all European companies, a global consortium of multiple company, American company, European company, Asian company, that are trying to put together a solution, a chiplet solution, and for the future of the software-defined vehicles.
Wonderful. I think that's well said. It's I can't believe we rushed through half an hour so quickly. It went really quick. I appreciate your time and your insights. Right. So from our standpoint, we look at Axelera as a real big player in the ecosystem, potential partner in all these activities that we're going forward with, and solving a problem that's close to both our missions, right? Which is, how do you make AI completely democratized? How do you make data movement more efficient and compute more efficient as a result? Because now it's no longer singular compute, it's distributed compute. And we're both part of an ecosystem that's growing, and looking forward to, as you say, what happens in what at the moment seems still like a Wild West with a lot going on.
Absolutely.
So thanks for coming in, and all the best with Axelera.
Thank you for inviting me today. It was great to talk to you.
Thank you for listening to Tech Threads, Weaving the Intelligent Future podcast. Join us monthly for insights into the evolving tech landscape and the future of chiplet technology. If you enjoyed today's episode, don't forget to subscribe and share it with your network. And stay tuned for more expert discussions. Let's weave the intelligent future together.
That's it. Keeping it simple. All good? Sound quality was good, right? Okay.